Hey guys, I do want to just start by saying thank you for continuing with us this far. This is Chapter 5, and it's been a little bit of a delay in getting this video posted. As you know, I did push back the due dates a little bit for Chapter 5. I'm hoping that helps you and these videos help. We're going to talk about conditionals and how if statements work and how if else's work. And in doing so, we need to talk about planning, decision-making logic, and kind of how algorithms flow within Java and in general. So let's talk about how to develop algorithms, and basically how to take the algorithm and transfer it from your mind to a computer program. The first thing you want to do is just plan out your logic, and one of the ways of doing that is simply by writing pseudocode. You take out what you're going to do. I need to brush my teeth, for example, and I will write down all the steps of doing that process. I need to go to the bathroom, turn on the faucet, get the toothbrush and the toothpaste, and basically you break every step down. You identify any algorithmic assumptions. That is, you identify things that you assume would work, but they don't really make sense when you try to do them. Anyway, and you break them down in decomposed parts so that they're easy to follow. You accomplish important steps in a given task, and most importantly, in this stage, you use everyday language. The next step in that process might be to use a flowchart, and this would allow you to see the steps in diagram form. The series of steps is connected by arrows. We use flowcharts, and we introduce flowcharts especially here at this point because now we're going to be doing conditionals and flow control. So there might be two different paths you might take depending on some condition, and so using a flowchart will show those various conditions. Programmers use a variety of shapes for different tasks, but for the purpose of this discussion, we're going to use a rectangle to represent any unconditional step and a diamond to represent a decision. First thing we need to know is an algorithm can be a sequence of steps or a selection or an iteration. So far we've done sequencing programs. Every algorithm we build has been a sequence of steps. In this unit, we're going to introduce a selection so we can choose one path or another. In a future unit, we will discuss iterations, looping, if you will. In a sequence structure, one step follows another unconditionally, and you cannot branch away or skip a step. And the flow chart for that is very straightforward. The flow goes from top to bottom. You're used to that in your Java programs. You run one statement, then the next statement, then the next statement, then the next statement until the program ends. That is the standard flow of a sequence structure algorithm. Decision structures look different. A decision structure involves choosing among alternative courses of action, and it's based on some value within a program, particularly a Boolean value, because all computer decisions are yes or no decisions, and we show that, or we reflect that in programming language by using a Boolean. A Boolean can have two possible values, true or false, and we use Booleans as conditions in every computer program in order to drive this control of flow. Now, allow me to just spend a few minutes when we talk about control of flow, showing you a programming concept that I use to show algorithms, and particularly flow control algorithms. This is a site called Lucidchart. You're able to log in with your regular Google account if you have one, and I can actually come here and build a quick flowchart. I'm not going to do anything crazy right now, but I want to show you a really quick flowchart. I can hit more templates, and I can just hit a popular template, which is just a basic flowchart. And when you open up this flowchart, it's going to give you some things, right? I'm going to go and use this template, and I'm going to show you how this works. All right. This is a flowchart. This is the process box. I'm not so concerned about that shape. I'm not concerned about that right now. I just want to show you process boxes, and I do want to delete this here and this here and this here and this here. and then I'm going to drag here an end box to the bottom, right? And I'm going to drag, we'll come back to that. But I want you to notice when I drag off of this, it says yes. And when I drag off of this side, it automatically says no. And you can see that color there. And I'm just going to say hungry. Am I hungry? All right. So let's just say on the process, come home from work. All right. And then I've got a am I hungry box. If I am hungry, I'm just going to make a quick process box here. And that process box is going to say eat something. Otherwise, don't eat something. All right, and then finally, I can drag off this box to this box here, drag off this box to this box here, and I can say end. All right, why am I showing you this? This is just a fast way for you to kind of diagram out your work if you haven't done that before. I want to make sure that this is connected, yes. All right, it's a fast way to diagram your work. You can build complicated flowcharts. The program works pretty well. I did not connect that well. All right, let's see if that, no, still didn't connect, so we're just gonna drag this over, there you go. All right, this program works pretty well. It's free, and it's just something you might wanna use if you're ever just building a flowchart. It's work in not just computer science, but other classes as well. And I just wanted to show that to you as you thought about developing and designing your own programs. We're gonna stop the recording here.